Hi everyone, in today's lesson we're going to talk about the exponent rules. So here's the goal. We will simplify expressions using the exponent rules. So let's go over the rules first. The product of powers property, which is a to the m power times a to the n power, is when you take a to the m plus n power. In other words, you would add their exponents. In an example such as the one below, x to the third times x to the fifth, the answer would be just x to the eighth. So you would add 3 plus 5. Here's a proof for that. X to the third is really x times x times x, and x to the fifth is x times x times x times x times x. Well, if I count them, there are 3 here and 5 here. That results in 8 x's. Another property that we have is when it's an exponent to an exponent. Notice that the second exponent doesn't have a base. It's attached to the base in the front here. In that case, what we do is we multiply the m times the n. So the rule is to multiply exponents when it looks like parentheses to an exponent. In other words, x to the second power times to the fourth power is x to the eighth power. You would multiply the two exponents. Here's my proof. X squared to the fourth power means there's x squared times x squared times x squared. There's 4 of them. Well, if I add them, 2, 2, 2, 2, that is a total of 8 exponents, or x's. The third property is the zero exponent property, where a to the 0 power, or anything to the 0 power is 1. So an example would be 7 to the 0 power is 1. That one's a little bit tricky one. You do have to memorize that one. The quotient property of a powers property means that if I have a to the m power divided by a to the n power, then I can go ahead and subtract the two exponents, m minus n. So it is the subtraction of the exponents. Notice that the base is still the same. So subtract exponents. And we always go from top to bottom. For example, if I have x to the 6th divided by x squared, it is x to the 6th minus 2, which is x to the 4th. Here's how I would prove that to you. X to the 6th is x times x times x times x times x divided by x squared, which is 2x's underneath. Well, if I have an x on top and I have 1 in the bottom, I can technically get rid of them. I could do the same thing with the other x's, leaving me with just x to the 4th power, which is the answer. So I'm trying to prove to you where these exponents or where these expressions are coming from. All right, so let's start combining some of these ideas. When you're combining like terms, remember that what you do is you add or subtract like terms only. So if they look different, you don't put them together. The second thing you do is you put them in order. So you're going to put the terms in order of degree. So usually we put the highest degree first, and then we go all the way to the one with the least amount of degree. And sometimes there are no x's, so we just put the numbers last. All right, so let's look at example 1. We are now combining like terms. We have 3x squared and positive x squared. There's technically a 1 there. So those are like terms. Therefore, we can combine them to 3 plus 1, which is 4x squared. Notice that when you combine like terms, the exponents do not change. The second one we have is a negative 5x minus 1x. When you combine them, you get negative 6x. And you are done at this step because x squared and x are not like terms, so you cannot go any further. In part B, what we'll notice is 2xy squared and positive 5xy squared are like terms. So what I would do is add 2 plus 5, which is 7, and leave xy squared alone. That's our final answer. And the last one, part C, I notice that negative 2x squared and positive 5x squared are like terms. So negative 2 plus 5 is 3x squared, and I'm left with the plus 5 at the end, and therefore that is my final answer. X squared and x are not like terms. Don't even think about putting them together. All right, let's go to the second page. We're doing great. So now what we're going to do is we're going to combine, use some of these properties that we had with the exponent rules and also combining like terms, okay? So you have to be careful when you use exponent rules and when you combine like terms. We're kind of mixing it up for you. As a matter of fact, let's go through and see which ones we would combine like terms with. So I would combine like terms with number 5 because there's an addition. So I'm adding, in this case, like terms, and 3 plus 5 is 8x squared, and I'm done with that problem. All right, let's look back again to see what else I can combine like terms with. Number 6 I can combine like terms with because there's some addition and subtraction there. So I have x squared minus 5x squared are like terms, so that's negative 4x squared. And then I also have plus 7x and minus 4x. So 7 minus 4 is positive 3x. And these two terms are not like terms. One is an x squared term, one is an x term, so we'll leave that alone. All right, let's see what else is there. Excuse us. There we go. Okay, so number 7 also has plus and minus signs, so we can add and subtract like terms. And here's what we have. We have a 3x to the third. There's nothing with that, so I'll just write, 9x to the third. So I'll just write 9x to the third. And then I see an x squared term. So negative 3x squared, but I don't see any other ones, so I'll just write negative 3x squared. Then my last one is the plus x and the minus 9x, and that is negative 8x. And none of these three terms are like terms, so we are done there. All right, see if there's any other ones we can add like terms with. Oh, number 9, I see it. Oh, that one's a long one. All right, so number 9, we have, let's see, we have negative x squared, and we have negative 3x squared, so that gives us negative 4x squared. And then we have positive 2x and negative 4x, which is negative 2x. And then our last part is 8 plus 9, which is 17. And none of those three terms are the same, so we'll leave that alone. All right, let's go back and do some of these exponent rules. So exponent rules are the ones that only have multiplication and division. There's no adding and subtracting. Notice that we don't say multiply and divide like terms. We say add and subtract like terms. So we did all the ones that had addition and subtraction first. All right, so let's go into the rules. According to the rules of exponents, when we have an exponent on the outside, we can go ahead and distribute it to the 3 as well as the x squared. So it's going to be 3 to the second power, and then it's x squared times, oh, I don't need a parentheses, so let me just, times 2 as well. So really, 3 squared is 9, 3 times 3. And x to the 2 times 2 is to the 4th power. So that is our simplification. All right, let's look at number 2. We have z to the 4th times z to the 8th. Really what that means is I have 4 z's here and 8 here. So I have a total of 12 z's. So this is when we add the exponents. I think this was the first rule, right? Whereas here we multiplied, or some people like to say distribute. All right, example 3. Ooh, we have a's and b's, okay? So what I'm going to do is just rewrite this so you can see it. A squared, and I'm going to put a to the 3rd right next to it, and then I'm going to put b and b to the 4th right next to it. So we do see the a squared times a to the 3rd as two bases with exponents multiplying. So we are going to add their exponents. So I have a to the 5th. I have 2 and 3 more is 5. And then here I have b to the 4th. But most people don't realize that b has a power of 1. And when you add 1 plus 4, you get b to the 5th. And these are not like terms, so we'll leave them alone as a to the 5th times b to the 5th. All right, let's look at example 4. Example 4, we are dividing these bases, so I know that I have to subtract the bases. And so I have x to the 5th divided by x to the 1 power. And 5 minus 1 equals 4. So my answer is going to be x to the 4th power. And we are done with that one. We did numbers 5 already, number 6, number 7, and last one, number 8. We have two bases of x being multiplied with their exponents, so we are going to add the exponents. And 2 plus 3 is 5, so it's going to be x to the 5th power is our final answer. All right, well, I hope this lesson was helpful. Thanks for tuning in and watching it. Looking forward to seeing you in class. Please bring all your questions to your teachers. Bye.